Quick experiment before we start. Open a terminal and run this against your own running Taskmaster app. curl xpost http localhost 3000.api.projects -h content type application JSON d name. Anyone can create this. That worked. No login, no token, no session. Anyone on the internet who finds that URL can create, update, or delete data in your database right now. Every route and every server action we built in Video 6 trusts the caller completely. That's what we fixed today. We're installing Next.js, wiring it to TypeScript, connecting it straight to the same Prisma database from Video 5 with the official Prisma adapter, building a credentials provider so users sign in with email and password, and writing the callback functions that decide what actually ends up on a logged-in user's session. By the end of this video, that same curl command gets rejected, and Taskmaster knows exactly who's making every request. Let's get into it. Why in Next.js, and how auth actually works. What a session really is. Strip away the library, and authentication is 3 moving pieces: verifying who someone is, usually with a password check; issuing proof of that, a session, so they don't have to log in on every request; and reading that proof back on every subsequent request to know who's calling. You could hand-roll all 3. Hash passwords yourself, sign your own tokens, set your own cookies, write your own session lookup on every route. People did exactly that for years and got subtle security bugs for their trouble: timing attacks on password comparison, insecure cookie flags, tokens that never expire. What Next.js actually gives you. Next.js, now developed under the Auth.js name, standardizes all 3 pieces behind a config object. A provider handles verifying identity, credentials, Google, GitHub, whatever you need. An adapter handles persisting sessions and accounts to a real database, for us, Prisma. And callbacks let you control exactly what ends up on the token and the session, which matters the moment your app needs more than just an email address on rec.user. Note, this series uses NextAuth at beta, the version built for the app router and server components. The setup shape is different from older NextAuth tutorials you may have seen. One central Auth.js file exporting handlers, not a single n.nextauth.js API route with everything crammed inside it. Hands-on, installing and configuring Next.js. Step 1. Install the packages. nm install NextAuth at beta, @auth Prisma adapter, bcrypt.js, npm install d @types bcrypt.js. NextAuth is the core library. @auth Prisma adapter is the official bridge to Prisma. bcrypt.js hashes and compares passwords. We're not storing or checking plaintext anywhere, same rule we set back in the database video. The central config file. Create auth.ts at the project root, right alongside package.json. Taskmaster auth.ts, new. The whole NextAuth config lives here. App, lib, @prisma. Import NextAuth from NextAuth export, const handlers auth sign in sign out, equals NextAuth providers CA. That's a valid empty config. No providers yet. Nothing wired to a database. We'll fill it in section by section, but this establishes the shape. One config object, to structure it into everything the rest of the app needs. Handlers for the API route, auth for reading the session on the server, sign in and sign out for triggering the flow. Step 3, the route handler. NextAuth needs an actual HTTP endpoint to receive sign-in requests, callbacks, and sign out. Create the catch-all route. App, API auth, NextAuth route TS. Import handlers from @APR. Export const get post equals handlers. 3 lines and every NextAuth endpoint, sign in, sign out, session, callback, is live under API auth/. That NextAuth folder name is a catch-all dynamic segment, the same bracket convention from Video 2, just with 3 dots instead of 1. It matches any path underneath, not just one fixed segment. Note, add auth secret to your .nv.local now. Generate one with npx auth secret. NextAuth uses it to sign and encrypt session tokens. Without it, you'll get a clear error the moment you try to sign in, not a silent security hole. NextAuth refuses to run insecurely in production. Hands-on, the Prisma adapter. Why an adapter, not just a callback? Without an adapter, NextAuth keeps sessions in an encrypted cookie only. Nothing touches your database. That's fine for small apps, but Taskmaster needs real persisted accounts, password resets, linked OAuth providers later, the ability to revoke a session server-side. The Prisma adapter gives NextAuth its own tables to manage that state. Step 1. Extend the Prisma schema. Open schema.prisma and add the models the adapter expects. This is a fixed shape NextAuth's Prisma adapter requires. not something we're designing ourselves. Model account. ID string at default UUID. User ID string, type string, provider string, provider account ID string, refresh token string, access token string, expires at inti, token type string, scope string, ID token string, session state string, user at relation fields user ID, references ID on delete, cascade, add unique, provider account ID, model session, ID string at default UUID, session token string, unique user ID string, expires datetime, user at relation references ID, on delete cascade, model verification token, identifier string, token string, unique expires datetime, add unique token. And add the reverse relations to your existing user model from video 5. Model user, ID string at default UUID, email string at unique, full name string, password hash string, created at datetime at default now, accounts account sessions. Notice password hash was already sitting on user since video 5. We built it in anticipation of exactly this moment. We just never had anything reading from it yet. Step 2. Migrate. npx Prisma migrate dev -add NextAuth tables. Same migration workflow from video 5. Prisma diffs the schema, generates the SQL, versions it in Prisma migrations. 3 new tables land in Postgres, none of them touched by hand. Step 3. Wire the adapter into Auth.js. Import NextAuth from NextAuth. Auth, Prisma, adapter, import. Prisma from @lib.prisma. Export const handlers, auth, sign in, sign out, equals NextAuth. Adapter Prisma, providers. Note, that lib.prisma.ts singleton from video 6 is exactly what the adapter needs here. One shared client, not a fresh connection every time NextAuth touches the database. Hands-on. The credentials provider. Step 1. Add the provider. This is where NextAuth actually checks a password. Update Auth.js. Import NextAuth from NextAuth. Import credentials from NextAuth provider's credentials. Import Prisma adapter from @auth Prisma adapter. Import Prisma from @libprisma. Import brick from bcrypt.js. Export const handlers, auth, sign in, sign out equals NextAuth. Adapter Prisma. Providers, credentials with email, password. Authorize async credentials equals const user is await prisma.user.find unique, where email credentials.email is string. If not user, return null. Const valid is await brick.compare credentials.password as string, user password hash. If not valid, return null. Return user. Odd, session, JWT. Authorize runs on the server. Every time someone tries to sign in, look a user up by email, bail out with null if they don't exist. Compare the submitted password against the stored hash with bcrypt.compare. Never a direct string equality check on a password, and only return the user object if it actually matches. Returning null is how NextAuth knows to reject the attempt. Note, session strategy JWT matters here specifically, because credentials doesn't support database-backed sessions the way OAuth providers do. NextAuth encodes the session into a signed JWT stored in the cookie instead. The account session tables we just migrated are still used for anything OAuth later. Credential sessions ride in the token. Step 2. Hash passwords on signup. Authorize only checks hashes. Something else has to create them. Wherever you build the signup flow, hash before you ever call prisma.user.create. Import bcrypt from bcrypt.js. Import Prisma from @auth-libprisma. Const password hash is await bcrypt.hash plain password 10. Await prisma.user.create. Data, email, full name, password hash. That 10 is the salt round count. Higher is slower to compute and slower to brute force. 10 is a solid default for a real app. You're trading a few extra milliseconds on signup for meaningfully harder password cracking if your database ever leaks. Step 3. Triggering sign-in from the client. Use client. Import sign-in from NextAuth React. Import useState from React. Export default function login form. Const email, set email, equals useState. Const password, set password equals useState. Async function handle submit React form event. E.prevent default. Await sign-in credentials. Email password, redirect to your dashboard. Returned, on submit handle submit. Class name flex call gap 3. Input on changing text email.target.value, placeholder email. Input on changing text password.target.value, type password, placeholder password, auto, sign in. This is one of the rare places we do need use client and real event handlers. Sign in from NextAuth React, runs in the browser, post to the /API auth route we built, and NextAuth handles the redirect and cookie setting from there. Hands-on, auth callback functions. Why you need them at all? Right now, sign in works, but ask your session for anything beyond an email address and you'll come up empty. By default, NextAuth keeps the token and session deliberately minimal. Callbacks are how you put more on there. The JWT and session callbacks. Add callbacks to the config in Auth.js. Export const handlers auth sign in sign out equals NextAuth. Adapter Prisma. Providers all ACS credentials provider. Callbacks async JWT token user. If user token ID is user ID, return token. Async session token. If session.user.id as string, return session. These run in a specific order, and the order is the entire mental model. JWT fires first, right after authorize succeeds. The user object is only available on that very first call, so that's your one chance to copy anything off it onto the token. Session fires after that, on every request that asks for the current session, and it only ever sees the token, never the original user object again. Copy the ID across in JWT, then read it back off the token in session, and now session.user.id is available anywhere in your app instead of just inside authorize. Note, this two-step handoff trips people up constantly, putting logic in session that assumes user is defined there. It never is. User only exists in JWT, and only on that first sign-in call. Every callback after that is working with the token you built, not the original database row. Reading the session on the server. With auth destructured from our config, any server component can check who signed in with zero client-side code. Import auth from @auth. Import redirect from next.navigation. Export default async function dashboard page. Const session equals await auth. If not session.user, redirect to login. Return h1 welcome back session.user.email. That's the whole protection pattern for a page. Await auth, check for a user, redirect if there isn't one. No middleware required for a single page, though for protecting many routes at once you'd lift this into actual Next.js middleware, worth its own deep dive later in the series. Locking down video 6's routes. Now go back and close the hole we opened with today's hook. Update app API project/route.ts. Import auth from @auth. Import next response from next server. Export async function post request equals session.user.user. Return next response JSON, error not authenticated, with status 401. Const body across request JSON. Const project equals await create project body name. Return next response JSON project, status 201. Run that same curl command from the very top of this video now, with no session cookie attached, and you get a clean 401. The exact status code we talked about choosing carefully back in video 6, instead of a created project. Recap and call to action. Let's lock in what changed. NextAuth.js configured through one central Auth.js, backed by the same Prisma database from video 5, via the official adapter. 3 new tables migrated in cleanly. A credentials provider that hashes with bcrypt and never touches a plain text password. And callbacks that carry a user's ID from that first authorized call, all the way through to every session check afterward, which is exactly what let us close the hole from today's cold open. In video 8, we take session data into the UI itself, showing the signed-in user's name in the dashboard, building a real sign-out flow, and protecting entire route groups at once with middleware, instead of checking auth on every single page.